Hello my friends, today we have a program which provided by Fieldpiece. Fuse Service are ambassador of the Fieldpiece products right now, and today we have a presentation from them, refrigerant leak detection, the right way to do it. So we're gonna check what kind of refrigerant leak detectors Fieldpiece has on their own and how to properly use their tools. So the first of all, we would like to start about the safety. So safety is always the most important thing we should all consider in the field. There are many dangerous items we encounter in the field each day and each job. Refrigerant burns, electrical and moving parts can cause bodily harm. Cut your finger, burn your skin, and etc. So all the time be careful with these items. Making sure you get home safe at the end of the day is a priority. So your family, if you don't have family, just make sure you have at the end of the day all fingers, your eyes, your ears, and health. So when it comes to the PPE required, it's recommended that gloves and eye protection be used. So Fuse Service all the time when you become to the other part of the team, we're providing the eye protection and gloves. Shoes covers and etc. things just for like a starter kit. We just recently started to provide to the new employees that bags, if you don't know about that. So the risk of frostbite should be always considered when working with refrigerant. The boiling temperature of refrigerant is always lower than ambient temperatures we work in, meaning liquid refrigerant on your skin will boil at atmospheric pressure. This can result in serious injury. If the system is leaking and holding refrigerant, there is a great risk of liquid refrigerant encountering your skin. For those of you that have not experienced this, be thankful. First, second, or third degree refrigerant can burn your skin, and it's just your skin can just fall apart from your body. So this particular presentation doesn't have any pictures. What could be, how can be dangerous these burns, but I saw them in my real life, how the guy just tried to open the refrigerant valve on the air conditioner unit and burned his arm, and it was absolutely like it's expanded maybe 2 times his hand after he burned, and he was out of the work maybe for 2 months just by one small accident, because he wasn't work with gloves and burned just completely with small amount of the refrigerant. The pressures we encounter during this process can range greatly, but the higher the pressure, the greater danger. So because we're working with R410, mostly refrigerant, which is regular pressure on high side is about 400 psi. High side is most dangerous part of the air conditioner units, so that part could be you have to work with high attention. The equipment and tool we are going to use, they have own pressure ratings. So the equipment does have own pressure rating. So if you see on labels of the air conditioning units, they are pressurized on the, for example, 800 psi. That means if you will make that pressure higher than that rating, the manufacturer won't guarantee you what it's gonna handle this pressure. It can explode. To where? To your body, to your eyes, to your colleagues, to your workers, etc. All right. What we're gonna do today? Why do we look for the refrigerant leaks? How do we look for refrigerant leaks? Practical application in the field, hands-on time with the tools. We have a few tools here, leak detectors, so we can play with them a little bit today. So the field we work in is time sensitive. The customer's comfort and the life of product are crucial. Making things faster and more effective matter to your customer. So if they have leaks, it's just a very good idea just to find it and eliminate in one place. I mean, without charging refrigerant, go home and after 1 month come back and charge them again. Because refrigerant cost right now for 10 tank, 25 pounds, about $500. So the price, it's become as a gold price. When a system is leaking, there is a solution to the customer's problem. We can solve it by fixing the problem. There are many methods for completing a leak check and repair. We plan to have you leave feeling more comfortable in these processes and how to implement them in the field better. So, why do we chase leaks? Here's the word, the customer is not comfortable. Why we have to chase leaks? Why we have to find them, that leaks? The system is not running efficiently or even freezing up. Premature equipment, compressor failures, product is being lost in refrigerant application, EPA requirements, system exceeding 50 pounds of refrigerant. So, the goal is to locate and repair any leak we may encounter regardless of equipment, capacity, or application. Your customer is depending on you to make the right repair for the first time. The customer is not comfortable because the system is not sealed, refrigerant is being lost somewhere, the refrigerant is leaking, you losing money, the customer losing money, so kind of inefficient process with work with all these parts. So the system is losing efficiency and possibly causing harm to the equipment. As we know, the refrigerant oil typically starts to break down with temperature 200 to 25 Fahrenheit. So when the compressor is getting hotter without the refrigerant inside, the oil inside of compressor is break down. So this is why it's very important to keep all the time the right amount of refrigerant inside the system, because if we lose some of the refrigerant inside, the compressor won't cool down efficiently, and that means we can burn the compressor. In many cases, the system is losing oil with the refrigerant leak. This can be attributed to early compressor failures as well. So somewhere system is leaking, for example in low side, on the evaporator coil side. That means in your practice you may saw a lot of leaks in the evaporator coil or in condenser coil. So we see there the oil spots. That meaning we're losing not only refrigerant, because the refrigerant is just a gas. We are seeing the oil spots. That means usually 100% we have a leak on this system. In our current world, we must consider even more critical products such as vaccines and medical products that requires a set temperature to be safe to use. If the equipment is not repaired correctly, this could have catastrophic results. Here we go. All right, so here's a part about saying the chillers. I want to skip it because here's a part which they said it's better to say if we're working with system more than 50 pounds. We're usually not working with system more than 50 pounds. We're usually working with residential right now, so I don't want to pay a lot of attention on this part. So, history of leak detection. This is dated method. So here's a finding leaks in the past involved the use of a halide leak detector. The device used an open flame and reactor plate. The heat would react with the chlorine in the refrigerant, causing a color change to the flame. So kind of just a small burner, which we try to find and burn something. If it's it's kind of dangerous thing because as you know someone, the R22, if you're gonna heat a lot, it is creating poisoning gas. After, if it's gonna burn higher than 400 Fahrenheit, it's creating the poisoning gas, which can cause lose your stability, and you can just fall front of the old air conditioner unit with R22 refrigerant. So this is dated method for finding leaks. The heat reacted with the chlorine gases causes a chemical reaction. Some of the attendees may remember using these years ago. Did someone use this method before? Old guys, dinosaurs of HVAC industry. Никто не знает? Никто не использовал такую хуйню? All right. So some may still own one. It's important to remember this device was only effective with refrigerant that contained chlorine. CFC refrigerant, chlorine, fluorine, carbon refrigerant, CFC. With the push by the EPA to reduce CFC refrigerant, this became obsolete. There are many great methods we will discuss in these becoming slides. So, how do we find the leaks? Visual inspection, pressure testing, and electronic leak detection. So what we're going to discuss of the different methods, what we can use to accomplish with tasks: visual inspection of the system, pressure testing the system, and electronic leak detection. Pretty much I used to use all these methods, as I mentioned, like a visual inspection. What we got? So, signs of oil present somewhere in the system, doesn't matter. It could be the line set, it could be a condenser unit, it could be just the evaporator coil, even it's with wet evaporator coil, it could be with oil spots, doesn't matter. Dirt collection on the areas what we have oil residue, so when just the dust goes through the through the condenser coil or evaporator coil, this oily spot is just to collect some dust. As any machinery you can drive with your vehicle, if you see the oil spot on the engine, that spot gonna collect some dusts on own. So pulling oil in a cabinet or near a component, damp insulation, corrosion on piping. So all these things, meaning it's something bad happening with your HVAC system. In my practice, I had to replace the compressor once, and without knowing, so I found what the compressor was burned, the system was empty with no refrigerant, and I was figuring out, oh, okay, I found the issue, the compressor is burned, one of the pin fell off during the overheat the compressor, and so refrigerant just blow off from the pin from the compressor inside. So what I decided, I ordered the compressor, replace it, everything goes smooth. After I replace the compressor, maybe for 1 week, and the customer called me back and said it doesn't work again. I said, what the heck, what's going on? I came back, found what the system is empty again, and what I found, the whole condenser coil was with oily spot like that. Absolutely, the whole condenser. Multiple oil spots I found there, and it was like surprise for me because the compressor was cost about $600, even like 4 years ago, and because it was like a starting of the business almost, so it was very crucial to me to just a waste of the money. So it was kind of our installation of HV, of the evaporator and condenser coil after that case. And we with 10 replaced first time without any license, without anything. We just had to do it because we had no choice. We did it for $1,500, very cheap. Just, I mean, she just paid, the customer, she just paid for the equipment itself. This next thing, nitrogen testing. System is found to be empty, newly installed or just repaired. It's all the time to purpose to use the nitrogen testing. Pressurize the system with nitrogen. The system will either halt or the surge begins. Never exceed the test pressure rating of the equipment. So if you will put more than, for example, the designed pressure to your system, as I said before, it can explode. In my practice, I've never seen what the copper pipes can explode, but I've seen some videos. I don't know, maybe some of you guys saw in the YouTube, maybe Iran or Iraq, some of the Arabic countries, there's HVAC guys pressurized the system with maybe oxygen, and it's just a fucking explode. It's made a very critical explode, so I don't know what's happening with these guys, but I believe some of them lost their hands or body, I don't know. So the history is unknown after that. It just was very big bump, I mean the gang. So holding the pressure to be sure the system is tight. Okay, the nitrogen testing is one of the most basic yet effective ways to check a system for leaks. Fieldman, S-man, refrigerant manifolds have a built-in tightness test for this purpose. So we have this wonderful manifold S-man. So if you will pressurize with refrigerant, about like a 400 psi for purpose of the checking the system, it shows you exactly very like a precise psi pressure of the system during the maybe like a 15-30 minutes when you're just checking what it's hold the nitrogen in the system. So test pressure should be listed on all equipment from the manufacturer. Never exceed the test pressures when doing the nitrogen test. And for sure, the nitrogen serves a few purposes for us in the field, because you're pressurizing the system during the brazing, for example, we have that wonderful pictures. It's showing when we are using the nitrogen, when we are brazing, what the copper pipes inside became clear, and if we are not using the nitrogen during the brazing, the copper pipes oxidizing inside. So oxidized particulars, they are collecting in the pipes and then goes to the TXV valves, filter dryers. Usually it's cause a system failure on TXV valves because it's a mostly restrictive, smallest area in HVAC system. So, where is it? Okay. Leak checking a system either for audible leaks or then soap testing is implemented. The pressure test after an install is complete. It's all the time we have to use the nitrogen testing. When the use of trace gas is introduced, the nitrogen is behind the trace gas. So that meaning when you wanted to check the system for the leaks, you don't have to put R22, for example, or R410. Right now it's more important because the refrigerant more expensive right now. So the method says you have to just mix the refrigerant with nitrogen. In this case, the leak detectors will be helpful in this case, because the leak detectors won't help you if the system just does have the nitrogen. So then a system isolation test is done. The evaporator, line set, or condensing unit is isolated to try to pinpoint the source of leak. So that means if we have three components of the system: condenser unit, line set, and evaporator, if you cannot find the leaky place, you just have to isolate each of the part. So you have to cut the condenser unit, isolate it, pressurized, and test it, for example, 30 minutes, each of the component. Maybe take 1 day for the test, because you just have to pressurize system and leave the equipment for the 1 day, 24 hours, for example, or maybe a couple of days, because you have to just go to another service calls or the installations. We had a lot, not a lot, but a few times, I know exactly, when the new equipment came for installation, the installer installed the equipment and it's leaking. It doesn't hold the vacuum, for example, or after a few days or a couple months, it's just all empty. It became like a few times already in our practice. Nitrogen purging tips. There are many new and innovative regulators in the market today, some with preset pressures for different applications, such as purge, test, and braze. So, do we have this thing with nitrogen regulator?
Yeah, I'll bring for you.
Yeah. So nitrogen is applied to the system at relatively high pressure and can be dangerous. Always make sure the regulator and any hoses being used are in good working order. When purging using nitrogen while brazing, ensure to apply not too much nitrogen pressure, as it can lead to cool down of pipe quickly and not forming proper brazing. So we have here's a wonderful nitrogen regulator, which has press presets test, purge, brazing, and off. So off is just it doesn't, and the nitrogen just doesn't goes through the pipe through here to this end. So brazing means it means it allow to run the nitrogen about 1 and 1.5 psi. If you don't have this fancy nitrogen regulator, it's usually very hard to find this 1 or 1.5 psi of pressure of the nitrogen. So if you're trying to braze the copper pipes with higher pressure, it can just blow to your face the liquid metal and you won't be able to braze it, or it's just a can cause of the holes in the copper pipes when you try to rebraze it or etc. So equipment manufacturer may not warranty if system components fails due to not using proper brazing techniques. How they will find about it, hard to say. Next one, electronic leak detection. So Fieldpiece does have electronic leaks detector styles: ultrasonic, heated diode, and infrared. So the ultrasonic detection method does work, but it's not commonly used. When implemented correctly, can have good results. It is generally used in larger system with much larger leaks. It doesn't offer the sensitivity levels for the infrared and heated diode detection methods. Always understand your testing equipment and read the manuals. We can be very successful with these tools when we use them properly. Not all tools work the same. Let's go over some differences. So ultrasonic detection. Ultrasonic detectors listen the very high frequency noise to alert the user of the presence of refrigerant or pressure leaving the system. So that means it's kind of just a small microphone, which is just making louder the pitching noise of the ultrasonic sound, and in some point it's just hard to find them that leaks through this kind of the method. So ultrasonic sensor listen to the very high frequency noises. Pinhole leaks in a pressurized system like act whistles, like a...
Can we stop and change battery?
Yes, un momento. The pinhole leaks in a pressurized system act like whistles. The ultrasonic leak detectors listens for the small whistles produced, which is far quieter noise than the human ear can pick up. So you won't be able to hear that whistle ultrasonic sound higher than 20,000 hertz. The human ear won't be able to detect. A good way to describe these are sensitive microphones. The higher the pressure in the system, the better chance you must hear the leak. There is skeptics and believers for this style of leak detection. The device generally requires a bit of skill and getting used to. Costas, we have a Costas who loves to use this ultrasonic method of the detection of leaks. He has a very nice small Chinese device for $100, which you can put the ears to your earphones, to your ears, and try to find the leaks in the condenser. I think this method it's very like successful, I believe, in some point. Here you go, and kind of useful if you have enough nitrogen in your tank. So the next one is heated diode detector. What we have here. No, this is not. So we have here old style heated diode detector. It does have inside small fan which is sucking the gas inside of the sensor, which is somewhere inside of this device. Right now I'm trying to find, read what they are saying here. This type of detectors works by heating the air, refrigerant, and breaking the molecules apart. So kind of the heated method as we mentioned before, when we are burning the gas which came out from the system as a chlorine by changing the flame. So here's taking apart the molecules. When the molecules are broken, a positively charged chlorine or fluorine ion is induced. The heated diode will detect these ions and sound the alarm either audibly, visually, or both. So this device can show how far this leak pinhole shows. So when it's higher level, it shows what it's closer to this nose. So heated diode units does have lifespan. The sensor in most cases can be replaced. The diode degrades with use. So it's need to be changed maybe like every 2 years, maybe this sensor inside of this device. The more technical explanation of how a heated diode sensor works. The heated diodes are semiconductors what heat a catalyst bead that reacts with the surrounding sample air. When refrigerant gases contact with this catalyst bead, it reacts very strongly in the form of the electric signal what we output using our instruments. So kind of very complicated explanation, but kind of semiconductor inside. We just understand what something touching this semiconductor, and it's just changing the signal. And this is device just trying to making higher level of this signal and shows on the screen or just on this electronic level display, maybe, I don't know how it's called. So the next, infrared leak detector, which we have right now, very modern day infrared leak detector. A good way to describe how IR infrared works is that on one side you have flashlight and on another side is eye. The flashlight shines at the eye until refrigerant comes by the blocks some of that light. The more refrigerant is in the air, the more that light is being blocked from being seen by the eye. That triggers the audible and visual alerts. So if we would say like this, for example, we have this wonderful infrared refrigerant leak detector. You can actually play with this a little bit, just to push it forward. So we have here these two systems. Oh, infrared refrigerant leak detector, heated diode refrigerant leak detector. So we have here infrared refrigerant leak detector. These two systems differ in that they utilize two different types of sensor. Both tools may look the same, but there are some key difference. The DR is infrared model. This unit will be quicker to recovery by 50%. The recovery time with these tools is 5 seconds. DR82 hold the same sensitivity specification of 0.03 ounces early. This tool would be used in the sweep motion with the tool zeroing to its environment. So that means if we have in some point, for example, we have on the middle the leak. So for example, in 6 inches from this leak, we won't have any signal. So it's just can show exactly the place where we can find the leak. Try to play with it. So this tool would be used, okay. The DR82 has 4 sensitivity settings: high, medium, low, and turbo. This setting should be used for very small leaks. Rapid movement can cause a false positive in this mode. So when you're using this tool, just have to move it slowly during the close the condenser or evaporator or line set movements. The DR58 is heated diode model, so we don't have this model right now with us. We just have the old one, the old model. Is good for testing leaks as small for 0.03 ounces yearly. So that means if the system is losing 300 ounces yearly, that means this tool can find these small, very small leaks. So it could be take 5-10 years to get empty the whole system. These tools can find them. I don't know how, but they're saying about it. The recovery time is going to be 10 seconds. So after you find the pinpointed hole in your system, for example, like in this picture, just to make sure what is like a really positive leak, you just have to keep on the clean space this leak detector. After 10 seconds, put back on the leak source and try to understand for 100% what its leakage space like a place, because as said the manual, if you will shake it very fast, it could positively falsing positive results. This why it's better to keep it all the time. 4 or 5 times for make sure what it's really leak source. These units have robust battery life, so it can work up to 18 hours. Here's a lot of, I would say, not useful information. So the main talking point here is sensor life, sensitivity, and the quality of the product. We don't make tools to say we have also one like this. So each of them they have for own purpose. We make tools what make the technician lives easier, faster and better. So here's some of the characteristic was they have like USB Type-C connector, and it could be charging, but it's not really useful information for this purpose. So how to find the leaks? Scenario number 1. The system just installed. The technician will run a tightness test with nitrogen. If the system is sealed and tight, no further action is needed. The system just have been installed and we are verifying the field install line set and fittings are tight. The system is pumped up to a desired pressure and left to hold for some time. This typically around 15-30 minutes. The pressure should hold and remain constant with little deviation. So if we have like a little rising of the pressure during the test of the nitrogen test after we install the new system, that is fine. Maybe in 15-30 minutes and it can fall for half or 1 psi nitrogen, I mean the pressure, but not much. The first step here is to again start with visual inspection and audio cue. 9 out of 10 times the tech will find this leak easily if the system doesn't pass the pressure test. So if we pressurize the system and it doesn't hold the pressure, obviously, we have to try to find where it's leaking. The tech should know where all brace and mechanical connection have been made, because all these points could be they have a very high risk to be leaky. These are the first places we look. The equipment installed could also be flawed or damaged from shipping or install. It is always important to check that pressurized items like an evaporator coil and on a residential split are holding nitrogen from the manufacturer. It is not always your leak. So, as I said, evaporator coils usually comes pressurized with nitrogen all the time. We put it there, the small piece of rubber inside, and if evaporator coil doesn't have the nitrogen inside when you are installing it, that could be means it's leaky. I mean, with no refrigerant coil means usually what is just could be damaged or leaky. It became leaky to our warehouse. Be sure when testing the nitrogen pressure never exceeds the system rated pressure. The S-MAN manifolds has this feature built in for tightness testing. If being implemented, this test will time the pressure test and account for temperature changes. This feature can save the technicians time and headaches. The refrigerant in the condensing unit should be released until tightness was confirmed. Interesting. Okay. In the event when install was deemed to be leaking, but the nitrogen test didn't easily locate the leak, the technician should move to trace gas and electronics. So if you won't find any leaks during the nitrogen test, that means you have to gonna use these wonderful Fieldpiece tools for leak detection. This is rare but possible situation the technician may find themselves in. Remember, this could be due and to a failed brace joint, failed mechanical joint, or a leak in the tubing equipment. In most cases, the technician is only testing the line set and evaporator at this time. This can vary based on the type of the equipment being installed. The use of electronics could speed the process up if the leak is not apparent in initial pressure testing. Soap testing could be implemented during the pressure testing as well. The system pressurized, and an approved soap product can be applied to fitting or mechanical connections. So recently we had a problem, or kind of the situation when some of you guys used not appropriated soap, which was cause of the corrosion of the copper pipes, and I saw a few of them in Slack. So make sure what the soap was approved for this particular copper pipes. If we had before the situation with walk-in coolers, when we applied the soap, which has salt inside of this liquid. So after a couple of months, the evaporator has like more holes than it has before, because the salt just ate all metal like copper. Again, the charge shouldn't be released during an installation until the tech can confidentially say the system is tight. So we have a charged air conditioner unit from the manufacturer. That means very expensive gas inside the air conditioner right now, for understanding. Make sure everything holds very tight in the system. No any deviation of the pressure on your wonderful Fieldpiece S-mount manifolds. And after that, you can release the refrigerant to the system from the air conditioner condenser unit. Scenario number 2. The technician arrives on a call and no cooling. The system was existing. The customer is not comfortable, or product is being lost due to temperature. The technician completes the visual inspection, finds no red flags. Tech now moves to checking the charge. The unit is found to be holding no refrigerant. We're tasked with correcting this problem. So, what you gonna do? Nikita, what you gonna do when you found no refrigerant in the system?
I have to put the refrigerant with the nitrogen together in a system, pressurize it, and try to find the leak. Or maybe the first I have to take a look on the pipes and find oil spots or something like that.
Yeah, here's a no red flags.
Okay,
Completes
in this case,
the.
I have to pressurize system with the nitrogen and refrigerant.
So yeah, all right. What, and then what else? What the further steps? You pressurized.
Okay, after that I have to use special equipment like the diode tester or ultrasonic, for example, and try to find the leakage spot.
You put the nitrogen
With the refrigerant.
with refrigerant.
Yeah.
But, for example, you put the refrigerant blows away like a what gonna means?
This means that the leakage spot is very big.
Very big, okay. The technician can implement the use of safe bubble solution with nitrogen pressure without using any. For example, if we have like a losing pressure, maybe half psi per 1 minute. it could be a not big like a hole, but could be somewhere. So let me see. So I believe is depending on the situation we have to just run all of these scenarios here. And in my practice, as I know, the first thing, we're pressurizing the system. If depending on how fast the system lose the pressure, we have to implement the other steps. For example, putting the nitrogen with gas to pinpoint the place where we can lose the pressure or the refrigerant. So, because if we have, for example, the condenser unit losing the pressure, we can try to bubble it, the whole thing, and we have to 1 gallon of the bubble soap, which we never have in our trucks. So in this case, it's better to use these particular devices to use if we don't have a lot of bubble and time to try to bubble everything in the system. So it's just to save the time in this scenario. So let's move to another one. So scenario number 3. This system is holding refrigerant. Now the technician begins to diagnose the customer issue. Props, tools are placed in appropriate locations. The system is deemed to be holding refrigerant, but suspected low charge. This can be indicated by a few measures: high superheat, low subcooling, and high discharge temperature. Who can explain the situation? What could be a cause? I mean, how we can find what the cause of this purpose? For example, Nikita was installed the system, and then Kostas was called to this system and found what system works non-efficient. What could be means this, Kostas?
Freon leak.
Why freon leak?
If it's high superheat and low subcooling.
It was installed in the winter time, never used till summer.
Yeah, I gotcha. System's undercharged.
Undercharged. Why? Because we have low subcooling or high discharge temperature, right?
Yes, because in the winter time we cannot charge systems as correctly. We're supposed to be wait when temperature outside and inside in the house more than 70 degrees.
All right, thank you. So, can we do visual inspection during this particular situation? I mean, what you gonna do? I mean, so you came to the customer house, customer unhappy. The system is new, but it's never used till these days, like hot days. And the visual inspection can say it's like no any leak spots and no red flags, no any leaks, everything is tight. Maybe it has some leaks, but it's very low leak, maybe like 300 ounces per year, which can be detected by these wonderful tools, leak detectors. So all the time we have all our trainings how to charge the system, right? Our team lead, Nikita and Tony, can explain how to do it correctly. If you don't know and have no idea how to do it correctly, they all the time happy to explain you. Summary. What we covered should help to make the technician more comfortable with the leak detection process. There are many methods being used. The proper repairs result in happy customers and customer retention. So that means if we found the leak in first place. Even if it's not fault after installation, maybe it's just like an old system and it's became leaky after 15 years because it was just like movement parts from the blower and other parts, or it's just the metal degraded because we have no idea what the China people using in production of these wonderful carrier Mitsubishi products. So all the time they really provide on us to provide comfort and product longevity. I mean the customers. Questions? Any questions on the material are welcome. We will do our best to answer them with verifiable data. Take down information for any questions you cannot answer. О, видали, они тут мне подсказывают. Если, говорит, есть вопросы, но я не могу на них ответить, то не стесняйтесь их отпустить. Now we move to a field exercise. We will try to facilitate the active leak to check over the one of the tools. If we can not provide, we will shoot. Короче, тулзы у нас есть. We have to try to use these wonderful tools in our air conditioner unit. We will just try to release some of the refrigerant, very expensive one, to show you how these tools works. All right. So let's do first the questions part. Huh? Yes. Go ahead.
There are three methods of find with sound.
Ultrasonic, infrared.
Sound, heated diode, and infrared. Which is better? So for
This, I mean, they saying in this wonderful presentation what all tool you can have, they are wonderful. They are just you can have both of them. For example, you have two COVID tests, which from Pfizer and another from the Moderna. And which test is better? Have no idea. They just have the different methods. So you can have both of them, or you can just have one of them. Because just to make sure for 100%, this particular place is leaky. You won't be able to disassemble this thing and find the 100 precise place where it's leaking, because it's have a fins inside, the aluminum fins, and it just can show you very close 1 inch wide the place where it can leak. Because if you will try to find, for example, this area, and you just have to make sure sometimes what for 100% what you have to move that aluminum fins in this particular place, because just for yourself, make sure for for example, you found first with this leak detector, is it? With this leak detector, what trying to moving this leak detector like this, and it's starting to beep this place. So it could be means it's placed here or here, but it doesn't say it's leaking here, right? It says just this place. In this scenario, because the system still pressurized, you can apply after that apply the bubble soap just for try to see visually what's this area. It's like bubbling. For make sure you can try to move that fins, aluminum fins, just right here. Because if you will damage these fins, it's hard to just restore them very accurate. And because if you will try to find like a move that fins here, then there, and then there, and customer will see it, what you just damaging all your like maybe 3-5 years old condenser unit. I understand you can have this kind of tool which is making right these fins back, but not all of us have this tool. So these tools just help you to find the place almost for 100%. And second, you may have used just for make sure for 100% what this part of this place is 100% the faulty. Okay. For example, you go to this like A test and the doctor said you have an 8, you will die after 2 years. And they're using just one test. You will never trust him. You just have to go to another doctor and ask him the second opinion. So the second tool is second opinion, right? Make sense? Nikita?
I have a question about the size of the hole. I mean, if we have a leakage, do we have a table or something like that so we can see that if our system lose pressure about 5 psi per minute, if we see this pressure drops, we know then that we have one hole, for example, one small hole. But if we see if it loses about 20 psi per minute, that means that a lot of holes. Do we have this table or it's just practice?
I believe it's just experience. If you will understand like, whew, my money blows out from this hole, where are they? You will understand like you will put more refrigerant there, I believe no. Or like a nitrogen. The nitrogen is cost money too. So you're putting more nitrogen, you're gonna like put the whole day nitrogen to the system just to try and understand where is it going.
So my question is, a few minutes ago you saw that we have a leak on the top of the condenser unit.
Yes.
But so we start from the top and we see the hole right there. We fix that hole, pressurize the system again and see that we have also pressure drop.
Yeah, in this case, for example, if the system still connected with all other components as a line set and evaporator coil, we just have to isolate each of the component, pressurize them, and make sure what each component is fine or faulty. Just for make sure, we just have to replace the condenser unit, because there is no reason to pressurize the whole system when we're thinking what just one part is faulty, the leaking.
Got it. Thank you.
So, questions? More questions? No questions? All right, let's try to release some of the refrigerant. I have no gloves with me right now, but I have wonderful tool to release. Here we have a 410 unit refrigerant. So I will just try to keep it like this, because the refrigerants should blow from this maybe 2 feet distance, and try to be closer to this released area. It still shows nothing. Because our money just blows very fast.
Awesome.
Can we make a hole somewhere? Like, is there a real situation? No. But So it's hard to say in this brand new unit how we can use it. So we might have to pee on this condenser a few years to start the corrosion process. I fixed a few times the condenser units which were peed by dogs for a few years. It was maybe like a 5-7 years old units, but because the dogs was peeing on the corner of the condenser unit, it was absolutely damaged by the corrosion because all aluminum fins was completely destroyed, and even the aluminum is fine. It was became to the copper pipes inside the refrigerant lines inside the condenser unit, and it became a lot of holes. So what I did, I just changed the small parts of these copper pipes on first, second, and third row of this condenser on the corner, and I believe that condenser still works great, and I hope. But the thing is, I had to cover this area with metal plastic. I mean the metal cover, because there was no fins anymore, because they was just completely destroyed, and I just fixed the copper pipe. So here's no any traces of the existing refrigerants after releasing 30 seconds ago, so I'm trying to do it again. So as manual said, it can sense 300 ounces yearly. So that means it's very small amount. So 300 ounces yearly means like you can divide these 300 ounces yearly by 365 days. 365 days multiply 24 hours. 24 hours per. So it's very small amount of refrigerant can be found by this infrared refrigerant leak detector. And let's try with another one.
Yeah, but we're supposed to be change filters first.
Filters? Which filters?
Okay, let's put old one.
The diode's still there? So as we mentioned, this tool heating the gas and break down to ions the gas. I didn't release yet, but it sends already something. You have to move the detector very slowly, just to try to find the leak place. As we see, this core, I mean nipple, holds very well. Doesn't release any gas here. Nothing. It doesn't work. Busted.
Replace just filter.
You think?
Yes, because we never replace them.
I sense it. No, something wrong here. Because it's not new, and Fieldpiece didn't send us yet the new tools for just a. Here we go. For training purposes. Do we have to use this filter?
You're supposed to be using.
I hope EPA won't find me. Okay, this works fine. There you go. So after we found the leaky place, we just have to keep on the clear place the leak detector, and then, for make sure, put them again to leaky source. Because this source not leaky anymore, it doesn't show anything. All right, that means we don't have any leaks. In my practice, I would say sometimes these leak detectors little frustrating and annoying, and you just have to make sure what this particular place is leaky, and as Martin mentioned, why we have to use, why they are different. We just have to use few different tests. Thank you for your attention, and I'll see you in the next time.